So this time it's about medication dosage instead of chemicals, but after experiencing swelling in his shoulder, Jack began to take an anti-inflammatory drug. His doctor prescribed 200 milligrams every 6 hours until the shoulder healed, and 20% of the medication dissipates each hour. So I want to be clear, it dissipates each hour, but it's every 6 hours that he's taking that dose. So each hour it's dissipating, hour 1, 2, 3, 4, 5, 6, then he takes another dose. So it's not just 20% over that 6 hours. So here's what's happening in the table. He takes his first dose. He had 0 in his bloodstream at the beginning, but now he has 200 in his bloodstream. This last column just thinks about the net change. So he went from 0 to 200. So his change was 200 milligrams. So now, how do I go from this 200 down to this 52.4? So what's happening to the 200? If I take 200, let's see, 20% dissipates, right? So I retain 80%. If I take 200 and just multiply by 80%, I would have 160. But that was only 1 hour, right? Question? Do you have 360? It's over your head? Well, I'm trying to go slow. Okay, I just want to show you that this is not just 80%, right? 20% dissipates, 80% is left. 80% being left, I would have had 160. So I want to break down what actually happened from the end of taking my medication to 6 hours later. It dissipated every hour for 6 hours. So every hour is 0.8 to the 6th, right? 0.8 times 0.8 times 0.8 times 0.8 for 6 hours. So if you take 200 and multiply by 0.8 to the 6th, that will give you the right answer. 200 times 0.8 to the 6th gives you 52.4. So I wouldn't expect you to know how to do that step on your own. That's why we're doing this together as a different type of application that you haven't done before. But the 0.8 to the 6th is coming from 20% dissipates each hour, and it's been 6 hours. So that's where 0.8 to the 6th is coming from. So then what happens? He takes 200 more milligrams. So 52 plus 200 is 252. Why is there this net change right here? Remember I went from 0 to 200? Now what? I went from 200 to 252. So the net change was only 52 more milligrams than it was last time. So now I'm going to take this 252 and again multiply by 0.8 to the 6th. So now I'm at 66.2. Then I add 200 because I took my next dose. So I'm at 266. So what was the net change? I went from 252 to 266. So my net change was 13.8. What's the difference between the previous? So then I take this and I multiply by 0.8 to the 6th. So after 6 hours, now I have 69.8 left in my bloodstream. And I take my 200 milligram dose. I have 269 in my bloodstream. What was the net change? Well, now I went from 266 to 269, so I only had a net change of 3.6. So I would like you to do the 5th row. So this would be at 24 hours. He's taking his 5th dose. So I'd like you to figure out, see if you can figure out on your own those 3 boxes based on what I just did in the previous rows. So you have what you started with. I've showed you what I've done each time. I'd like you to try that fifth dose. And you'd add 200 and have 270.7. So the net change between those 2 rows is only 0.9. So basically this is like, there's your 70.7. How much is left in his system before the 5th dose? We already figured that out, 70.7. How much is in his system after taking his 5th dose? We already figured that out, 270.7. So those are just questions from the table. And then it says Do you think the net change in medication level, so this fifth column over here, is converging or diverging? So that's an important vocabulary term of this unit. What does converge versus diverge mean? Converge means it's getting closer and closer to what? 0. So is this converging? Yeah, I think so. Diverging would be like it's getting bigger and bigger every time to infinity. I can't ever add them all together. So yes, it converges because it's getting smaller and smaller. I want you to change question number 4 a little bit. So it says the net change in medication each hour can be modeled by this function. 200 times 0.262 to the n minus 1 power. Well, if you don't recognize this 0.262, that's just 0.8 to the 6th. So I'll just show you on my calculator, but 0.8 raised to the 6th power, they've just rounded that to 0.262. So they're just using the rate for R of 0.262 just for rounding purposes. So it says estimate the change in medication level. Don't do the 30th and 40th dose, just do the 8th and the 9th dose. So I want to show you how to do the summation for the 8th dose. So if we wrote this as a summation, it would be the sum from 1 to 8 of 200 times 0.262 to the n minus 1 power. Right? I'm plugging in 200, 200, 200, 200. It dissipates. And I'm doing this for 8 doses. So I want to see what I have in my bloodstream after 8 doses. And that's how you do it. It's under the math key. So if you could do that summation and then also do it for 9, 1 to 9, we just want to compare the net change, right? We're assuming that it's converging. So we're just kind of proving that it's converging to 0. So do it for 8, do it for 9, and see what you get. It's in the 270s. So you know you're doing it right if this is around 270. And if you can't get it to come out on your calculator, I need to troubleshoot that you don't know how to type this in correctly. It's under math summation. It's at the bottom. You want to make sure that their parentheses, this is the biggest problem I see usually, their parentheses need to stay outside your entire equation. So there should be these summation parentheses that you never touch. All your stuff goes inside it before you press enter. And you should get 271 with a decimal. It's 271.05 if you do it correctly. If you didn't, let me look at how you typed it in. Oh, I used 0.8 to the 6th. So you're right, we rounded it. Math summation, if I do it from 1 to 8 and I just use 0.262 raised to the n minus 1, you're right. 270.99, yep. 270.99, what is it, 997 or something? Okay, yep. And then if I do it for the 9th, did you say, Garrison, it didn't work on yours? If I do it for the 9th, 271.00 for this one, 271.00. So to get the net change, you subtract those two numbers. You do 271.00, 271.00 minus 270.997. See how the net change is just 0.003? So it's approaching 0. It's getting smaller and smaller every time. Formula that we did on containment ponds. A sub 1 over 1 minus R. What's the maximum amount in his system? You know what the original amount is, A sub 1, and you know what the ratio is. So calculate it for me. What's the maximum amount that's going to be in his system? So you're taking 200 and dividing by parentheses 1 minus R. 0.262 is your R. Make sure you put parentheses in your denominator. So what do you get? The maximum is 271. Point something, but I mean point zero something. So it actually already has achieved the maximum at like, 5 doses. So what? So just to wrap up this idea, I just want to show you what a graph of this could look like, but just for the ease of time, we're going to go from 0 to 24 hours on the bottom, and it's easiest if you just count by 50s up the side so that it fits. So we're going to put our milligrams going up the side. So this is our milligrams, this is our hours. And if you were a doctor or a pharmacist, you'd want to look at the highs and the lows in the bloodstream, because someone might come to you with pain because it's wearing off too quickly. So you might need to adjust the dosage based on the person's pain threshold, how quickly it's wearing off. So we're going to plot 0, 6, 12, 18, and 24 because we have these concentrations on the front. So at time 0, maybe if I do it in marker, at time 0, they start at 0 and then they take their first dose. So I'm just going to draw this kind of vertical line that they went from 0 to 200, right? And then it tapers down to what? What's our first low? 52, right? So our first low at 6 hours is now I only have 52 left in my bloodstream. I'm not sure if this is a perfectly straight line, but there we go. And then at 6 hours, we take another 200 milligrams. So it jumps up to 252 in our bloodstream when we take our second dose. And then it fades down at 12 hours to how much? At 12 hours, we're down to 66. So I don't know, just estimate where 66 is, like here at 12 hours. So it kind of goes down again, and then it shoots up to 266. And then it goes down to 270 something. And then it goes up to 270 something. And then it goes down to 70 something again. And then it goes up to 270 something. Right? So it's just these highs and lows. If you were the doctor or pharmacist, you want to look at the person's kind of low level here and upper level here. And you might need to adjust their medication based on the low and the high line. If they're feeling too much pain, they're going too low. So I said, like, how could you adjust medication to keep the level between 100 and 300? Maybe I can't go below 100 or I start to feel I feel a lot of pain at 6 hours. What could you adjust? What could you change? So you could try changing the hours, right? So you could try just changing the hours to 5 instead of 6. So how would that change my summation? Now I would go from 1 to infinity of, I'm taking 200 milligrams. How does it change my ratio right here? Remember how we got to 0.262? It was 0.8 to the 6th power. So we'll just change our ratio 0.8 to the 5th power. What if we just change this to 0.328? How does that adjust our lows and our highs? Does it give us too high or too low? Right? If we wanted to do the infinite sum, you do 200 over 1 minus 0.328. Let's just make sure that we're not going to overdose our patient. Because they want you to kind of stay at 300, let's say. So what do you get as your maximum when you do that infinite sum? Yeah, you get 297.6. So we haven't overdosed to over 300, and we're definitely going to draw up that bottom baseline so that we have a little bit more left in our system after so many hours. Because you'd have 200 times, what's 0.328? And then plus 200 times 0.328 plus 200 times 0.328. So after 3 hours of just dissipating and adding, I'm more at like the 94 level. So maybe that's going to keep the pain down kind of thing. All right, so we did 360.